Hey, so what's up, guys? In this video, I wanted to design, I actually wanted to work on something I've been excited for a long time. I wanted to work on a real-time operating system for a PIC16 microcontroller. Now you may be wondering, what's the purpose of that? Well, the purpose of it is that sometimes, you want an RTOS on a lower memory constrained device, but there really isn't much options available for doing that. In this video, I thought I would start looking at designing an RTOS. So let me show you the setup I have. So this is setup I have here. I actually have, three LEDs connected to a PIC16 F171 microcontroller, and of course, an effective for programming. So when I turn power on, I currently have this application running that just flashes the LEDs at 500 milliseconds. Now, let's say we wanted to flash each LED at varying rates. Let's say we wanted to flash LED 1 at 500 milliseconds, LED 2 at 1 second, and LED 3 at probably 2 seconds. Yeah, we could do an interrupt-driven system to achieve something like that. But having an RTOS, or even like a kernel or a scheduler to really handle something like that is what we really want to achieve in this series. So we're really looking to multitasking on this device, but this device has a limited amount of RAM, limited CPU speed, and it just makes it really difficult to do something like that. The best way you could do is like a cooperative system. So with a cooperative system, each task is giving up control to the next task. If you're doing like a preemptive multitasking system, it's more complicated to implement. We could interrupt tasks and switch between them. So basically, this is the structure we want. So we want to have tasks. Of course, could do something like a Finite State Automata, a Finite State machine to achieve something like this. We have two tasks. We have task 1 and we have task 2. And basically, each one of these tasks will be like a little small program within the larger program. So it's like a threaded environment. And we want to do something in task 1. Then when task 1 is finished doing what it wants to do, we want to give it to task 2. Task 2 will do what it needs to do, give it back to task 1. And, then we just keep repeating the cycle. And that's how our system runs. So this setup we have here is simple and it's very inefficient. Something like this would be very inefficient because we don't really have a scheduler. We don't have anything that helps switching between these two tasks. Suppose task 1 is taking too long to do something, then task 2 will be starved. And that's not something we want to happen. Let's look at how we can do this a little more effectively with the PIC microcontroller.